availability in a profile-driven
in a profile-driven world. Yeah. So
who came up with it?
And the translation to that essentially for VMware is this thing that we call storage policy-based management. This is the overlying framework for all of our technologies for virtual SAN and for virtual volumes. And so before we get into some of the details around what SPBM is and how it works and what it supports, we're going to talk a little bit about virtual volumes first. And so virtual volumes is sort of the answer for management to traditional array infrastructures. As you may imagine, for those of you that are storage administrators, usually when you build a data store on one LUN, this tends to be a bit of a data store centric or an array centric approach to managing. Everything is managed at the data store level. The storage has no idea what the application is, it just sees blocks or data. As opposed to an application centric, which is what we consider virtual volumes to be very application centric. Another way of looking at it, traditional infrastructure has many LUNs tied to many data stores, and every single one of those data stores has a very specific class of service, whether it's disk type, quality of service, dedupe, encryption, whatever the characteristics of your array are, they're tied to these individual LUNs. And some people like to say that LUNs suck. I don't know if you've ever heard our podcast, it's a very common thing that we talk about because LUNs they're old, they're a pain. I mean, it's a very high level of managing all of your virtual machines as compared to virtual volumes, and I'll show you some of the key differences. But the key pain points in traditional infrastructure before virtual volumes, at least with VMware, is number one, there's no visibility into the storage. Virtual administrator has to ask his storage administrator for some space that he can build a data store. So he'll get an Excel spreadsheet possibly with a bunch of IQNs, and he'll try to determine, is this backed up? Is it being protected? Is it being replicated? What are the characteristics? Is this thing on flash? Is it on spinning disk? There really is no visibility from the virtual infrastructure to get detailed information about your storage, your underlying storage. And so the second thing is, as we sort of alluded to earlier, is the fact that your management, all of the classes of service are assigned at the data store level. So if you've got 100 virtual machines sitting in the same data store, they're all going to get the same exact class of service. And that's not usually the case. Not every virtual machine is built equally. They don't have the same requirements. You might have a web server that might have more or less requirements than, say, a SQL server or, say, take your pick on servers, but everyone has different requirements, and throwing every virtual machine into the same bucket, the same LUN, with the exact same class of service is not exactly the most application-centric approach. And so what virtual volumes does is we start with this storage policy-based management, and what we do is we assign at a very individual disk, whether it's the entire virtual machine or even the individual disks within your virtual machine, we can assign very granular policies. And we'll take a look at what some of these policies look like. But by assigning these very granular policies, we can ensure that every disk gets exactly the class of service that it needs, no more and no less. And then the other thing that's great about virtual volumes is that these policies, they're set up in advance, but no storage is consumed until you start spinning up your very first virtual machine. So unlike LUNs where you're provisioning, you're pre-allocating space up front, and then you're defining all of those policies on those individual LUNs, it's a bit of a retail model because you have to keep repeating that every time you build a new LUN. That's not the way we do it with virtual volumes. With virtual volumes, we set up front what the policies are going to be, and then the virtual administrator can start provisioning virtual machines and getting them on the right class of storage, getting the right capabilities, whether that's replication, data protection, etc., all built inside of the policies. Slightly different architecture for virtual volumes. There is no file system, there is no VMFS, and some of the great things about that is that because we're not using VMFS, we're not doing VMFS snapshots, which tend to be, anyone take a VMFS snapshot before? VMware snapshots, anybody? Good times? Yeah? Yeah, exactly. We did a session last year at VMworld called Snapshots Suck, and I guess that explains how I feel about many snapshots, but we've greatly changed the way, the architecture in the way virtual volumes handles snapshots for your VMware infrastructure. And so the way it works now, everything is done through APIs. Every storage vendor has a VASA provider, which is that little VASA diamond there. It's a piece of software inside of Virtual Volumes that's each individual vendor, storage vendor, builds and owns and manages. And that's how we manage what the policies are being done. So if you create a new virtual machine and you identify those policies that I was mentioning earlier, all of that goes through the VASA provider. And the VASA provider then starts to provision storage on the array natively. These are native objects that sit on the array. And the beauty of it is that picture I had earlier with all those LUNs sitting on there, well, with Virtual Volumes, you can have one data store, one storage container tied to one data store. And all your virtual machines can sit in that same data store, but they get their own individual class of service. So no longer, we're decoupling the management as well as the performance from the data store level, and we're now assigning individually to each individual disk what the performance characteristics are going to be. So it's a much more effective way of handling your virtual infrastructure. And then, as I said, we also are decoupling the I/O from the data store. So now we have these little, this is the only time you're going to hear me say LUNs when we're talking about virtual volumes, but we have these little 4 megabit LUNs that are not data LUNs. They're essentially, it's like an address book. When the virtual machines power on, that's how the storage knows which files on the array belong to which virtual machine. So I power on a virtual machine, those binding and unbinding operations are handled through this protocol endpoint, which manages the I/O for each individual virtual machine. All data services, not Flex clone, this is not a NetApp conference. Clones, snapshots, all of that are offloaded immediately to the array. So when you create a snapshot within VMware, even if you're doing, whether it's an API call or whether you're just doing it by right-clicking on the virtual machine, it's immediately going to the array and creating a snapshot. They're still managed snapshots, what VMware calls, because you can still see them in the tree of snapshots inside of vSphere, but it's not doing the old VMFS snapshot that you might be accustomed to, which takes a very long time to delete and restore. And lastly, the part that we're here to talk to you about today is the fact that it's all done through this storage policy-based management. So a typical example would be, you've got a data store on the left in VMFS, you've got a database server that needs to go into some data store. Because my performance is tied to the individual data store, it's going to sit on my performance data store and then be assigned SSD. That's when I provision my virtual machine, it's going to reside on that SSD as an example. Whereas with virtual volumes, let's just say I've got 400 virtual machines, and I don't necessarily need the operating system on all of those virtual machines to be on my most expensive media. So maybe if I got a hybrid array, I could throw my operating system on spinning disk if I wanted to, or I could throw my and then throw my database on my highest grade flash media. Or if I have a larger model and I'm selling virtual machines for customers and they want to buy a cheaper virtual machine, I might have them consume that through whether it's whether it's VRA or whatever consumption model you have for upper, you can actually have them provision that through a storage policy-based management, but then the operating system can go on a C drive, and then the database can actually go on flash. More than media types, you can do other things like assign the snapshots, the replication policies, data protection, all of those things can be assigned inside of storage policy-based management. Now, what you can specifically configure within storage policy-based management depends strictly on the storage vendor that you're choosing. For example, if you use Nimble is going to go ahead and they've got a pretty extensive VASA provider support. They've got snapshots built in, their replication is built into their VASA provider, data encryption, the application policies. They've got a ton of different support for their virtual volumes. If you've got a NetApp, for example, you'll see some QoS, you'll see RAID type, things like that. So what you see when you go into VM storage policies, if you're doing it with a traditional array vendor, you're going to see very different classes of service or options when you're building your policies. Now on the left, I've got a vSAN policy. And so as you can see, this is the overarching management for both our vSAN and virtual volumes. Same exact interface, I'm clicking on VM storage policies within vSphere, and then I'm setting my settings inside of there to build my policies for my virtual machines. So the end of the virtual volumes conversation is pretty simple. When people ask me why would I consider virtual volumes, I say 3 things. It's simpler, it's faster, and it's smarter. It's simpler because I don't have to build a million LUNs, and I don't have to reinvent the wheel every single time I provision a LUN by assigning the storage characteristics. I go away from the retail model and I go to the wholesale model. So much more simpler architecture. It's faster because I'm offloading all of my performance to the array. So even my backups are faster now because it's not a VMFS snapshot. These are instantaneous snapshots done by my array vendor. And then it's also smarter because of the policy-based management. My virtual administrator now has much more visibility into the underlying array. It can tell me what media type it is, whether it's being replicated, is there a QoS policy. But also, my storage vendor has some visibility into what these data bits that are sitting on the array, what virtual machine they belong to. So there's more visibility from both the virtual administrator and the storage administrator. So a little bit about vSAN, and fortunately for me and you, we've got some technical experts in the room that are the big brains for virtual SAN. But I wanted to cover a little bit about what vSAN is and sort of how it pertains to storage policy-based management. Anybody in here not heard of vSAN? Great, my two storage experts are the only ones that have not heard of vSAN. Excellent. So moving on, some of the use cases that we've been seeing with virtual SAN have been business critical apps and virtual desktops. But the last couple of months, we've been seeing a growing amount of folks considering it for cloud native apps as well. But as you can see, there really is a pretty broad variety of use cases for virtual SAN. I heard Pat Gelsinger, our CEO, say at Dell EMC World last week, he was quoting himself from 2 years ago, and he sticks to his story, and that is that within the next few years, everything's going to be on HCI. So pretty bold statement, but I definitely see the logic in it. And so much like virtual volumes, same issues. I want to build policies in advance before I start provisioning my virtual machines, and I have the ability to apply these policies to a large amount of virtual machines. And so I can change a policy on the fly if I want to, and assign it to all the virtual machines that have that policy. So the same policy. Now the difference is, as I mentioned, if you look in a virtual volumes policy, depending on the array vendor, you're going to see varying different storage capabilities. vSAN, however, has 10 key storage capabilities that are available as of vSAN 6.6. And so same thing when you're defining a policy, you basically go into VM storage policies, and then you can go ahead and edit the different types of policies. One of the things I think are really cool is if you're talking about RAID levels or storage provisioning, you can use this what if API, which will tell you if I'm thin provisioning or if I'm going to set this at RAID 5, how much actual disk space am I going to use? And it'll actually bring up this example for you. So there's no guesses as to exactly how much storage efficiency you're going to get with the different types of RAID types that you would choose when you're building your policies. So these are informed decisions. The other good thing is there is granularity. You can assign a policy at an individual virtual machine level, or you can dig deeper and assign them to the individual virtual machines, much like you can do in virtual volumes. So some of the main policies, and I won't dig deep on these because I definitely want to save time for Michael to talk about how Veeam can integrate in here. But some of the policies that are in vSAN are the number of failures to tolerate for your virtual SAN. And there are formulas to decide exactly how many hosts are required, how many copies of the data. And again, when you're setting this up, you can choose the what if to see exactly how much storage you're using. There's also RAID 5 inline erasure coding, RAID 6 inline erasure coding, which is a little bit more efficient, but different requirements in terms of the amount of hosts required. Software checksum and disk scrubbing, which is new in vSAN 6.6. You can set IOPS limits inside of QoS limits inside of your vSAN policies as well. So if you get a certain amount of virtual machines that can want to only exceed a certain amount of IOPS, you can predefine those inside of your policies. You can identify the number of disk stripes per object. A new one here is also the ability to do force provisioning. This way you can allow it to violate one of your policies if you wanted to. So it's another way to make sure that you don't actually go down, but you can set the force provisioning in vSAN. And object space reservation as well, which is new in vSAN 6.6. And yeah, so vSAN's been around for a couple of years. I think it's how many generations now we've been around? 6 generations, but it's only been about 3 years? It's a pretty aggressive cycle. I mean, you guys, there's like a new vSAN version about every 6 months. So I feel really bad for my coworkers that have to constantly write the documentation for it. But we started off early 2014, and many people, the word on the street was that vSAN was basically, good for labs, but not for production. But as it started getting up, I think the real test was 6.2 was when we started to have some really, enterprise-ready features. And 6.6, I think, has been probably the largest and most well-received edition of vSAN that we've got here. I think one of the biggest ones that I hear my co-hosts talk about all the time is the fact that there's no longer a requirement for multicast. So that's a big thing within our customers that are very happy about. So if you have any questions about vSAN, though, we've got a bunch of guys that are here in the room that will stick around and chat with you. But the other good thing about vSAN and virtual volumes when you're talking about policies is that if you wanted to try vSAN or if you wanted to try virtual volumes, you could migrate to them non-disruptively. There is no, and they also coexist. You can have virtual machines that are on both and assign policies, part of it to virtual volumes, part of it to virtual SAN. And so in this demo, it's a pretty short demo, but what I'm trying to show you here is that I've got a virtual machine that's up and running in production and it's sitting on a vSAN data store. But I've got some arrays that I want to actually use. Let's go ahead and play that. Can you see that? See, it's moving. There we go. It's moving, right? Yeah, there we go. So I've got this data store here. I'll go into my vSAN data store and I'll see this test one. I can see all the files for this virtual machine are sitting on that data store. But if I go over to my virtual volumes data store, that does not exist yet. So I haven't migrated over there yet. But the beauty of it is I can actually assign policies when I'm doing a storage vMotion to this virtual machine. And so I can, I've already predefined my policies, but I want to go ahead and, change. I'll do a storage vMotion and then assign a specific virtual volumes policy that's for my operating systems, which might have a less maybe it's not all flash, for example, might have deduplication enabled, but it'll go ahead and show me which data stores meet that requirement. And then my vMotion is off and running and non-disruptively moving this virtual machine over to a VVol data store. And I know that it's got the right the class of service that I need because I've done it by choosing an SPBM policy. Now the one limitation obviously is that I'm onesie-twosieing it. I'm right-clicking on one virtual machine and I'm doing it one at a time. You can automate that with some scripting, some Power CLI as if you wanted to. But there are probably some fancier ways to do that, and I'll let Michael talk to you about that on how Veeam does some really cool things with migrating with policies. But as you can see, I've non-disruptively migrated this virtual machine from a vSAN data store over to a VVols, and I've assigned my policies before I even migrated. It's a pretty simple process. The big question we get a lot of times is, can you do this non-disruptively and can they coexist? And the answer is yes, yes. So, Michael?
Cheers, Pete. So, firstly, I guess, is there any questions in regards to SPBM, VVols, vSAN, before we kick on about how Veeam can keep those protected and doesn't look like it? Cool. Is anyone using VVols? Cool. What storage array are you using?
It's next-gen storage.
Okay.
What was it?
Next-gen.
Next-gen, awesome.
Which is now Pivot 3, right?
Yes.
Okay.
Great QoS.
And we spoke yesterday, right? So, cool. And I'll try and touch on those as well. So really, from a backup type supported, so we don't have the ability to go in, and this is both for vSAN and for VVols, in that we don't have the ability to leverage our direct SAN or direct NFS into those, because ultimately they're not presented out from VMware. So we have to use either MBD SSL, so it used to be network block device prior to vSphere 6.5. With 6.5, it's forced it down to that SSL, so everything is in that secure tunnel as it comes through. Benefits of that is easy, really easy to set up. It's just a case of having a Veeam proxy that can see over the network that the vSphere hosts. Can be any storage, we don't care what that is underneath, where we're going, it's ultimately we're just focusing on that virtual machine. Really fast, it's really fast with 10 gig, right? Is anyone still running 1 gig in production? So,
way to shame your audience.
Sorry. But, so it's really fast with 10 gig. We were talking about this, right, at the VMware booth last night. So, really there's not too much difference between our performance with our network mode, our network block device mode, and our direct SAN. Now with 10 gig is really that same speed and performance from that. And it gives you that out of band protection. So because you're using something away from that vSAN or the VVols stack, we're able to pull that data out of there. Only if it's painfully low on performance sometimes, if you're using anything other than 10 gig, and we have to traverse everything through the ESXi system, so potential impact against those ESXi hosts, even performance implications to the ESXi or to the virtual machines that reside on that. We also have the hot add, so the virtual appliance mode. That's where we put one of our proxies on each of the hosts, and then we leverage that same way. So again, easy to set up. There's a sprawl of proxies depending on the size of the environment, but ultimately what we're going to do is we're going to pick the relevant proxy to then start taking that data from a VVol implementation. We're going to just pick the best suited proxy, and I'll touch on what we do in the vSAN world when we get down to the smart logic piece. So it's using existing VMs on there, or you have to roll your own, and obviously the consideration there is that potentially more Windows licenses required if you're going to use that appliance mode. But if everyone's gone to that 100% virtual deployment, then obviously that's the way to go. You don't want to have those physical proxies or management servers to have to manage. Not as mature. That's really, again, we're still developing that. We've not just forgotten about it, and I'll get on to the smart logic piece that we do within vSAN. But again, if that proxy is going to sit on that ESXi host, it has to be sized to allow for that workload or the data to be moved through that. So if you're already sitting at an 80% utilized on your ESXi hosts, then virtual appliance mode either add more hosts or potentially you're going to have problems with utilization there. So, and it can be slow because again, you're traversing that whole vSphere stack. So we've actually supported VVols right back since vSphere 6 and Veeam Availability Suite version 8. So we've been able to take these backups from that both MBD mode as well as virtual appliance. So they use exactly the same backup job method. In fact, if you have a mixture between VVols, vSAN, just normal VMFS virtual machines, there's actually no different. You don't have a VVol backup job or a vSAN backup job. It's ultimately the same, and we still have the same disk files or configuration files within that. It's just managed very different from a VMware point of view. So apart from the path that it comes from or the policy that's set to those VVols. So now I just want to give this guy a massive shout out because he kind of did my job for me, so well done, Luca. So big shout out, he's done a really good, it's maybe getting on a bit now from an age thing, but he's done a backups, a performance versus between VMFS and VVols, and that's what we're really just going to shout out here. So for example, if we look here, so forget about that absolute performance type thing, but you can see the throughput being around that 305. I don't want to cut off the video. 305 meg throughput, but ultimately when you look at how long that job took and how much data is being transferred, you can see that it's a lot faster with the VVol implementation. But also, again, don't worry about the performance there, because when we look down onto that ESXi host and we drill down to that VMDK or the virtual machine, you can see the impact on performance in a VMFS is, so when we're creating that Delta disk or that VMware snapshot, we create the Delta, or we orchestrate that Delta disk to be created, all the new writes hit that while we're taking the backup from that read-only VMDK in a simplified manner. Whereas with VVols, because of the snapshot mechanism, which Pete will cover in a second, we don't have that impact on the performance. So actually, you can see the time between, so the VVols is taking just shy of 20 minutes, and I think that says 32, 33 minutes for the VMFS, but bear in mind the impact of performance on the ESXi host, the virtual machines on the VMFS could all be affected by that. So the VVols is much more efficient and gets you what you want in a much smoother backup window.
Yeah. Yeah, and so the reason why they're more performant is pretty straightforward. Two totally different architectures when it comes to managing a snapshot. I like to say that for a lot of folks, is there anybody in here, and I don't want to shame anybody, but is there anybody in the room here who believes that a snapshot is a backup? Of course, my co-host, excellent.
Wood chipper.
Yeah.
Get in the wood chipper.
Yeah. And so I like to consider a VMFS snapshot basically an undo button. If you're doing some upgrades, you're checking something, you're patching, you do a snapshot, whatever. Certainly a way to get back to a recent state, but not something that you want to keep around for more than a day or two, because the longer your snapshot is around, the less I/O you're going to have. And the reason for that is with a snapshot with VMFS, what happens is your main VMDK is writable. You go ahead and create a snapshot. This isn't a full copy of your virtual machine. This is essentially a redo log. And now vSphere is going to point all I/O to this new snap VMDK. Right? So now my I/O is writing into this snapshot, and then I'll take another snapshot. Right? So now vSphere is going to start writing all new I/O into my additional snapshot here, creating another redo log. And now if I want to start looking for some of that data, I now need to look in multiple places to find that data, which can be very time consuming. Also, if I want to actually delete my snapshots, before I can delete them, I need to then it takes a very long time to copy that data into the original VMDK before it actually will get back to me. Smoke them if you got them. I've seen some snapshots take hours. I'm sure some of you could probably beat that, but their snapshots with VMware, depending on how long they've been and how much I/O has been written to it, can be a very painful process. With virtual volumes, it's completely different. What we do now is it's just an API call to the array. So now we're going to offload that. So it's essentially some metadata manipulation. And now my virtual machine has an instant snapshot. vSphere, of course, is still going to look at that snap VMDK. Now this is the tricky part. This snapshot is not writable. This is a read-only snapshot. So what we've done with virtual volumes is we've swiveled or inverted the pointer from this snapshot into the main VVol. So the snapshot itself is never in the I/O path. So I've got this instantaneous snapshot available if I want to restore it, but it's never been in the I/O path. So all my I/O stays in my main virtual volume, which means if I want to go ahead and restore a snapshot with virtual volumes, essentially what I'm doing is creating that instantaneous snapshot. vSphere is going to create a backup copy of it first, which again is an instantaneous copy. Then it's going to go ahead and revert, which is again metadata manipulation. So a quick revert to my main VMDK, delete the snapshot, delete the backup. So much faster process. So even if you've got an application that's doing a backup that calls on a VMware snapshot, if you're using virtual volumes, that's going to translate into a virtual volume snapshot, which translates to an API call, which is an array-based snapshot. Much faster to restore and to take original snapshots.
Yeah, I guess just to go back to, like, so this one, in that if from a VVol perspective and Veeam, we're going to initiate this snapshot to take place. We're then going to pull the data out of that. But meanwhile, the new writes are hitting the live, exactly what Pete said. And then once we're finished, we remove this snapshot again. But because we don't then have to consolidate these new changes back into the live, we haven't had to impact the performance on that. Just on the whole VMFS side, does anyone actually use VMFS snapshots for patch updates or like those little checkpoint restores at all? So yeah. So I've got something from a Veeam point of view that I'll show in the demo about how we can alleviate that potential pain there because I guess one of the key things there is that's great and it works really well because it could be just for a short amount of time and the short amount of data that you're pushing in. It's when you're talking about scale and you potentially forget a snapshot in place, and then that grows and grows and grows, and then that commit is a massive headache, right?
Michael, the way to alleviate it is to go to VVols. Fair enough?
Yeah, we'll take that one. So, how do we restore? Again, it's no different from a Veeam point of view. We have the ability to still use our instant VM recovery, so we're going to present that backup file up into vSphere, and we're going to start running that virtual machine from the backup repository. Granted, at that point, it's going to throw up an error and say, look, you're not on an all-flash tier of storage. You're not matching that storage policy-based management capabilities that you've assigned to it. But ultimately, you're back up and running in minutes, and then you can use storage vMotion to bring it back into the policy that you need it to go into. We also have quick rollback. So this kind of goes into the about taking a snapshot for the Windows updates or some sort of patch testing, etc. Is quick rollback it doesn't have to, we don't have to use that instant VM recovery and present that from the backup storage. What we'll do is, because we leverage change-block tracking from a VMware point of view, we know what's changed. So we're only going to send back the blocks that you want in between those two restore points. So it could be really quick to bring it back, and at that point, everything's still on the same storage policy and everything's back up and running in no time, and there's no downtime to that either. So it's pretty good how we inject that data. Obviously, from a restore point of view, from Veeam is we could do that entire VM. We could do it the traditional way, and we could just copy that into the original location on the correct storage policy. We could also do those hard disks. We could do files, config files, etc. But also we've got the ability to use our explorers against those VVols. So really, ultimately, there's no different, but the performance of that snapshot methodology is the massive pain point that's being taken away at that point. So yeah, when it comes to restoring though, you do get the option, because we are vSphere tags, or we're SPBM aware, is that we've got the ability to restore back into that correct. So if we are doing an entire VM recovery, we've got the ability to go in and choose these policy-based data stores, whether that be VVol or vSAN. So we're pushing it back into that, and we're aware of that. Migration, so P mentioned around if you've got a storage array VVol capable, and you've upgraded to vSphere 6.5 or 6, and you want VVols to start, and you want to migrate your VMFS, and you're going to use the same hosts and the storage, then absolutely. Storage vMotion is going to get you there without any downtime, and it's going to be really easy. Yeah, you've got to right click and you've got to do that to each one, or a script. Alternatively, if you've got your old legacy vSphere environment, and then you're looking to build out a new HCI or another infrastructure with VVol capabilities, then we have something called quick migration. It's included in the free, so you don't even have to be a Veeam customer. You can just take this to your customers or into your own environment. And what it will do is allow for those where there's no link between the two sites, apart from a Veeam proxy that can dip into both environments. It'll allow us to take it from that VMFS and push it into a VVol or vSAN implementation over in that secondary location. So there is downtime, it does take it down, but ultimately that cross-link, that site-to-site type migration is there for that purpose. And again, it's on the free version. So yeah, it's going to reconstruct the VM to a VVol target. So obviously over on that side, you have to have all your SPBMs all created and so forth. But ultimately, if you've got that there in that greenfield type or brownfield type site, you've got the ability to do that. The only caveat there is that it needs to be using hardware 11, which I believe is probably a caveat of VVols, right?
And quick side note on that. So if you're going to do a migration to a virtual to another location, you need to make sure that the SPBM policies are sitting in that other place that you're going to migrate to as well. The current version of VVols does not synchronize the policies from one location to the next, but that is definitely on our roadmap. So you would essentially, if you're doing some sort of failover or migration, you'd have to precede that target location with your existing SPBM policies, so it knows to migrate that to the appropriate storage and assign the appropriate classes of service to the target location.
So from a vSAN point of view, we've introduced, and it's kind of been pretty quiet and under the radar. I don't know why we haven't shouted about it more, because ultimately it's using that hot add, that appliance mode, if you like. And what it does, so you've got a proxy on each of your ESXi servers, and you've obviously got vSAN distributed across all of those hosts. What Smart Logic actually does is allows us to use vCenter to determine where the data blocks reside, and then uses the appropriate proxy to be able to pull the data out. So you're not having to go to host 3 when the majority of VM's data, or VM1's data, is residing on host 1. So there's some clever logic, smart logic if you will, being able to go through and pick where the blocks are residing so that we can pull them out in a more efficient way. So these vSphere tags, so part of the SPBM, so the storage policy-based management is vSphere tags. So one, why wouldn't you be using them? Simply because you add a virtual machine to your environment, and then the next phase before vSphere tags would be, okay, we need to back it up. Or you forget, and then it's not backed up, and then you lose the data if that dies, right? The beauty about vSphere tags is that when you create that virtual machine, you assign a tag, then Veeam are able to leverage that tag in a backup job, so that we'll dynamically, automatically add that virtual machine to our backup job, and it will just continue that retention, that cycle that you've assigned. So that gold, silver, bronze, tin, paper type approach to how often, what's the frequency of that backup that you require. So I'll just show you here, so it's really easy to create these vSphere tags in a VMware environment. There's actually PowerShell scripts out there that I can share as well as part of the PowerPoint. But so I've got the bronze backup, the bronze replication, etc. So being able to really pinpoint what virtual machines need to sit in which bucket, and then what job we can use. So both from a VM backup job, we can leverage vSphere tags as well as a replication job. Yeah, and you can add them, so it's automatically going to define what that backup job looks like. So this is what Jace McCarty, right? Do you want to?
Either way, yeah. So we got a coworker of mine that he's a PowerShell guy, and he created a quick script that gives you the ability to, maybe you've got a lab environment and you want to get the existing, you don't want to recreate all the policies that you have in your one vCenter environment. If you want to spin it off for some test and dev, there's a very quick script, and there's a little bit.ly URL on the bottom of the page here, but essentially it's just a PowerShell script that will take your existing SPBM policies, export them, and then give you the ability to import those into a new location for you, whether it's test and dev or whether you're doing a migration process. You know, some environments can have 10, 15, 20 policies, and you don't want to have to recreate those yourself, and so being able to export those and then import them is a pretty handy tool, and we do it through PowerCLI. And we shared that through the bit.ly link there on the bottom. So.
Yeah, so I guess the use case for this, it could be that you've got a test and dev environment that has a VVol capable array, or you're using vSAN in the capable array for your test and dev, and you're just trying out this functionality, but you've gone through and you've created 100 policies, right? Or those bronze silver type approach. And what we can do there is use that script to take those policies, and then when you're in the process of migrating to your new environment, you can then just import them in. And there's also, so this is one thing that I didn't get a chance to do before this week, I had kind of a bit on, but is the ability to actually add this to the back of a backup job. So when we're backing up the VMware, the vCenter appliance or vCenter server, being able to bolt this onto the end as a custom script, so that it just spits it out as part of that to somewhere that you define that. So you've got that ability. Also, another use case is robos. So if you've got your main data center, why not have that same policy created in your robo sites and different locations? You might as well keep that same consistency. I was thinking something uniform like. But yeah, so that's there, and I'm sure Jace won't be able to sit still and keep doing stuff like this. He's telling me some weird stories about it. So, and then finally, so who's a VeeamON user? Who's seen VeeamON? Like it? Do you look at it every day? Yeah, it's pretty powerful for what it is, and we don't really shout about it enough, I don't think. In that, so one, it's going to give you the monitoring and reporting against your vSphere environment as well as your backup. But the other thing is Business View. So Business View kind of rips out all of that technical information, and this is where you can start defining SLAs. So you can SLAs against your recovery time objectives, recovery point objectives. But what we can do is we can actually import on a vSphere tag basis all of those tags into here, and then start running reports against that. So if you had replication job that required to happen every hour, and you could have a report that then defines and shows how many times that's been successful against how many times it's not. So then when you come to ask or speak to the board, and you can show them, okay, we've had 100% success rate when it comes to recovering from our VVol environment, and we haven't had any failed backup jobs based on these reports, and you can define them in that gold, silver, bronze. So you can start to see how it takes away a lot of the administration, the silos of storage admins, the vSphere admins, and the backup admins, and being able to just consolidate that down and be able to just spit out a report on that as well. So it's not really VVol related, it's kind of a vSphere, it's the vSphere Veeam web client. Does anyone use that? Did you know we had one? So I guess from that, it's VVol aware, it's VVol vSAN aware. I literally cannot see that. Yeah, well, here we go. So instead of just going directly into the vSphere web client and enabling that, we decided to put it into our enterprise manager. And the reason for that is our enterprise manager is to be the overarching manager of a distributed environment, right? So we wanted to put it in there so that we could distribute that installer out to any vSphere client, that vCenter server that we have in our environment. And it's very simple in that we obviously add our vCenter servers because that's what we're using to back things up from. We come in here and we can check that host. I've already installed it prior to this, but ultimately make sure that it's installed, make sure the version's correct, and we can go through and remove that if need be. Then if we jump into our vSphere, you'll see it there for a short while, but just to double check that we've got the right version, we see it in our, we check our plugins and make sure that it's enabled. Then back to home, and this is where it's quite really powerful from this point of view, in that over on the left-hand side, it gives you a VM overview. So how many VMs do you have? How many are protected? How much full backup size is being utilized? And just various high-level information there. Then it will give you how long the VMs have taken from a backup point of view. So it gives you can go down to a 14 or 30-day retention period. Then it gets into the repositories, and then it goes down into the jobs, so the jobs that you've had running. Up in the top left-hand corner, if you saw it, it gives you just a brief overview of how many successful backups, how many failures, etc. It also integrates with Enterprise Manager that we saw, so all the RESTful APIs that we promote out of there, as well as VeeamON. So VeeamON is still capturing information from there. And then just before that finishes, so I mentioned about the snapshot piece. So you probably can't see that right at the back there, but we've got an option called Quick Backup. So Quick Backup is exactly that. We're going to find where that virtual machine resides in a backup form, and we're just going to update and give another restore point, another incremental backup against that virtual machine. So that's still going to go through in a VMFS world. It's still going to go through. It's still going to create a snapshot. It's then going to remove the snapshot, and then it's going to offload that to the backup storage, right? What that means though is that you're not going to be stuck with any old snapshots on your vSphere environment, but you're going to have another restore point on your Veeam backup server for that machine. And you can do that, you can pick, so where I right clicked and you go down to backup, you've got the ability to select data stores, you've got the ability to select folders, resource groups, anything that any construct that you have within there. So the other two options in there is Veeam Zip. So Veeam Zip is literally zipping up a virtual machine so that you can take it and put it into another system. It's kind of one of our first iterations of the backup, but it's using the ability to migrate that virtual machine.
Nice. Yeah, and so from a VMware perspective, if you're storage policy-based management sort of is the overarch. If you're going to use HCI and you're going to use our virtual SAN, fantastic. If you want to use your traditional arrays to manage, absolutely. We've got over 40 partners, storage vendors that are certified in virtual volumes and over 70 different virtual volume arrays that are supporting virtual volumes. This is growing continuously. We've got some new folks that are actually going to be announcing at VMworld. So this is a continued support from VMware to support virtual volumes. And the real reason is because we understand that not everybody wants HCI, and maybe one day that will be the case, but there's just a lot of people that are using VMware and vSphere, and it's painful in many ways. Like we talked about, the operational model for traditional VMFS is just not as easy as it is with virtual volumes, and so big support from our partners that we certainly love to work with. Tons of arrays that are supported, and but whether you're doing vSAN or virtual volumes, we truly believe that there's one SPBM to rule them all, essentially. So that is the overarching thing, one SPBM. So yeah, that is all we have. We're going to stick around for questions, and I just want to thank you guys for coming. And yeah, we're here for questions. Thank you.
Please don't forget to fill out the survey as well. I know my boss will be looking at that. And
Oh,
I
yes.
really want to be fired.
One note, if you like this session, my name is Pete Flecha. If you did not like the session, my name is Michael Cade. So keep that in mind. And that's it, yeah?
Thanks, guys.